Be exam ready. Achieve top grades. Trigonometry Part 1. The Grade 7 to 9 Challenge. Part 1. Concepts and Skills. SOCA TOA. Sine rule, cosine rule, and exact values. Here are our learning objectives. By the end of this lesson, you will be able to apply SOCA TOA. That means use sine, cosine, and tangent ratios to find the missing sides and angles in right-angled triangles. Use the sine rule. We are finding missing sides and angles in any triangle using A over sine A, B over sine B, and C over sine C. Use the cosine rule. Find the missing sides and angles using A squared equals B squared plus C squared minus 2BC cos A, including with obtuse angles. Find areas and exact values. Use area formula, which is equal to half AB sine C, and recall exact trigonometric values for 0, 30, 45, 60, and 90 degrees respectively. Finally, we're going to be looking at how to select the correct technique. So we'll discuss how to choose the most efficient method for a given triangle and justify the choice. Concept number 1. Finding sides and angles. Examiner tip. Label the sides hypotenuse, opposite, and adjacent relative to the angle first, before choosing SOCA TOA. Here's the first question. A right-angled triangle has hypotenuse 12 cm and one angle of 30 degrees. Find the side opposite this angle. Now, we need to start drawing the triangle before labeling anything. So we are going to draw our right-angled triangle like so. Here's our 90 degrees angle, and we got the hypotenuse, which is 12 centimeters, and one of the angles is 32 degrees, so we'll choose this place to be our 32-degree angle, and the side facing this is going to be our opposite. Now it says find the side opposite and do 3 significant figures. So let's lay out our SOCA and TOA. And what we're going to do now is we're going to highlight all the information that we've been given. So in that case, what we're going to be highlighting is the angle. So the angle for sine of for 32 degrees, you can use your calculator and get the values for sine, also the value for cosine, and also the value for tan. So sine, cosine, and tan can be highlighted. Then you see that you also been given the hypotenuse. Okay, so we can highlight the hypotenuse in SO and the hypotenuse in CA. Next one, we're going to be highlighting the opposite. So the opposite is given as O. So therefore, let's highlight O wherever we can see O. So like you can see the first formula, the only formula that we can pick is SOH. S-O-H. So we're going to construct a formula triangle from this, and the formula triangle will be there. And O is going to be the subject of the equation because we don't know the value for O. So we're going to put O is equal to the hypotenuse multiplied by sine. I'm putting sine afterwards because the angle comes after. Okay, we don't mix up the angle with the other numbers as you're going to see here. So hypotenuse is 12, and then you're going to get sine of 32. Now, I just told you we're not going to mix up the numbers and the angle. So for example, if you put 12 after 32, it becomes confusing. So that's why sine is written after after the number 12. And the answer for that is going to be 6.36, which you can get by using your calculator. Right? So that's for the first question. Now the second one says a right angle triangle has opposite side 8 centimeters and adjacent 5 centimeters. Again, I'm going to draw a triangle to make it clear what's happening. So we got our angle here. We don't know the angle that we've been told. The symbol is theta, so that's what we're going to use. The opposite is the side facing it, so opposite is 8 centimeters, and the adjacent is going to be 5 centimeters. Now let's see, of all the formulas we can use, that these are our tools in our toolbox. Let's see which tool is the best one to apply to use here. Okay, so we got theta. We don't know anything about the angle. However, we know that the opposite is what we have been given. So instead of highlighting, you may also circle them. So we got opposite highlighted and or circle. Then you got A, that's circle. Now you are going to be looking for the angle, and that is requiring sine, cos, and tan. So let's circle sine, cos, and tan because we're looking for the angle. Therefore, it could be any of those formulas. Now, the candidate formula that is the best, okay, or our best tool to use is going to be TOA, and you can use your formula triangle from there. And what we're looking for is we're looking for the angle that we need to work out. So it starts like this. So it's going to be tan of the angle, tan theta, is going to be the opposite over the adjacent. And the opposite is from the drawing, you can see it's 8 over 5, which is equal to tan theta. Now we're going to send tan over there, so it lays bare just the angle. So that's going to be theta is equal to tan inverse. So opposite of tan is tan inverse of 8 over 5. And that gives me tan inverse of 1.6, which you can already work out from the calculator. And to one decimal place, that's going to be 58 degrees, 58.0 degrees. Okay, so I hope that you have been able to understand how we do these two questions, and you will be able to now apply the idea over here. So on to the next one. This is your turn, so you can apply the same idea and try to solve these questions. You can pause the video here, and I'll see you on the next slide for the answers to these questions, okay? And you can compare your work with mine. Now, here are the answers, and so for the 4 questions, and hopefully you've got all of them correct. Let's move on now to concept number 2. Now, concept number 2 is about applying sine rule. So here's our second tool in our toolbox. So if we are to use the sine rule, you will remember that there are 2 formulas for this. The first formula is A over sine A equals to B over sine B equals to C over sine C. Now, you may also remember that the same formula has all the terms flipped. So sine A over A equals to sine B over B and is equal to sine C over C. Now, we apply this when we are looking for angles. And we apply this formula, we're looking for sides. It's just convenient to pick the right one. Okay, so first question is to do to work out that in a triangle ABC, the angle A is 40, angle B is 65, and side A is 8 centimeters. Find side B to 3 significant figures. Now, in that case, let's draw a triangle. It doesn't have to be, it will not be to scale, so you can draw any triangle. Don't worry about which side is longer, as long as you got the sides placed So you got A, B, C for the vertices. Now small a opposite uppercase A, B is opposite, lowercase b is opposite to uppercase B, and same for C. Okay, right, so we've done that. Now let's collect the data from that question. So angle A is going to be 40 degrees, angle B is 65 degrees, and then side A is 8 centimeters long. Now let's look at sides that are opposite each other. We know we need to work out side B, so I'm going to put a question mark here so we can easily identify the one that we're going to be working on. Now, okay, so that involves two pairs of letters, and these are A and B. Now I can write, because we're looking for sides, so the first formula that I've written at the top is the one we're going to be using. Okay, right, okay, and the same goes for the examiner tip. It says that, so use A over sine A equals to B over sine B is equal to C over sine C for sides. And as I just told you, and sine A over A is equal to sine B over B. That's for when you want to use the angles. Okay, right, so A and B are involved. So let's write A over sine A and B over sine B. And we can do the substitution right away. We don't know about B, so we can keep B as it is. And B faces 65, so that would be over sine 65 degrees. And then you have A, which is A 8 centimeters on top of sine of 40 degrees. Now, we can therefore cross multiply the sine because we need B by itself. So A 8 sine 65 degrees on top of sine of 40 degrees. Okay, and in that case, you're going to get, using your calculator, you're going to get sine of sine of 65. So from the calculator, I can work it out. So that's going to be B equals to 11.3 centimeters to 3 significant figures. Okay, so now moving on to question 2. In triangle A, B, and C, you got the sides have, two sides have been given. So again, I'm just going to be drawing any type of triangle really. Okay, so we got A equals to, it does not really matter, it's not to scale. So B equals to 9 centimeters, and C, we don't know about C. So we are not putting a question mark there because we're not looking for it. Okay, and remember, uppercase letters opposite the lowercase letters, and then that will be capital C and that will be capital B. Okay, so C is not required, what we're looking for, and now you have also angle B given, which is 70 degrees. So that pairs off with this one, and that will pair up with that one. So if you remember, if we're looking for the angle, so we start with sine on top. So it's going to be sine A over A, and that's going to be B over sine B rather over lowercase b. Now because we're looking for sine A, alright, so sine A is on top of A, which is 7, equals to sine B, which is sine of 70 degrees, on top of 9. We can cross multiply that 7 across to the other side, and therefore we can get sine A equals 7 sine of 70 over 9, and that is going to give me a value. And then what you do after that is you do sine inverse of whatever the value you get from your calculator. So let me write it here. So sine of 70, and that's on top of 9, and the angle that you're going to get is 46.9 degrees. Okay, now you will be able to have a look at this, and while I get the other page uncovered for you, and therefore you should be ready for the question for you to practice on. So pause the video here, and I'll see you on the next slide for you to be able to compare your answers with mine. And as you can see, I have explained everything on there, and I've used the formula whichever is appropriate. If you are looking for the side, use the lowercase at the top. If you're looking for the angle, use the capital letters, or with the sign, of course, at the top as the numerator. Okay, now we're going to move on to concept 3. Now, in this case, we are using the cosine rule. And you get the cosine rule as part of the examinative. So your examiner is giving you the formula, the right formula, and it says use a squared is equal to b squared plus c squared minus 2bc cos a when you know two sides and the included angle. Included means the angle that lies between two other sides that you know of. And then you also have a formula for finding out the angle as well. So just like for sine, you can use a formula for finding side, which is on the left hand side, and I'm just going to write it here. That's for sides, and this one is for angles. Okay, now that you know which formula to apply when, let's look at a question. Now in that question you got a triangle again, so let's draw a triangle, and it doesn't matter where you put the letters, it's not to scale. That's the good thing about it. So you're going to get, let's say you're going to go A, B, and C. Now B is 7 centimeters, C is 9 centimeters, and angle A is okay. So A facing A, capital A. So that's where the included angle, it has to be included. Okay. And what are we looking for? Yes, we're looking for A. And the formula, because we're looking for A, it has to start with A as the subject. So A squared equals to B squared plus C squared, take away 2BC, and then cos A. Now, there's one thing that you need to remember. When you are using a formula, in that case, we're looking for A. So remember, when we're looking for A, the formula ends also with A. All right. So if you start with side C, you're going to finish with angle side C as well. Right. So let's do our substitution in that case. And in that case, we are going to have, we don't know about A. What we know of is we are going to look for A by substituting the values of B, which is 7 here, 7 squared, plus 9 squared, minus 2 times 7 times 9, and then cos of angle A, which is 52 degrees. And remember, the whole thing is equal to A squared. Now, in that case, when we're looking for this, you need to have your formula, the calculator ready, and that is going to give us, so A squared is going to give us 52.4, and then A will give us square root of that number, square root of 52.4, and that is going to give me 7.24 centimeters. Okay, now moving on to question 2. In triangle ABC, so let's draw the triangle, and then okay, so we got A is 10 centimeters, B is 8, C is 6. At least we know A is the longest side, and then we got A is 10. So then you have 8, which is the other, well, shortest, slightly shorter side. So that's going to be B, 8 centimeters long, and then you have C, which is 6 centimeters long, and that's our cm here, cm units. What we're looking for is the largest angle. Now, therefore, it will be facing the largest opposite side. So to find the largest angle, we look for the largest side, so which is this. And therefore, we know definitely that's going to be the largest angle we need to be looking for. And the other angles, okay, we're not interested in the other angles. So what we're going to do now, we're going to start the formula with the angle, with the cos. So the second formula that you can see right at the top right corner. So this is going to be, now we're going to modify, we don't need to modify, it's already in that form. So cos A. Now, as I said to you, here you're going to start with A. If you start with A, you end up with A. So what do I mean? So the lowercase letters, so that's going to be B squared plus C squared minus A squared. So we finish with A, and then underneath you're going to get those two letters back, so B and C again. Okay, so first we always write the formula before we do any substitution. So cos A is going to be equal to, so we're going to do the substitutions as they should be, like that. Okay, all the squares, whenever you do substitution, don't forget you need to put the brackets. Now that takes care of any negative values. Well, length is not going to be negative, but in other instances, when you do substitutions, you put brackets. Not in this case, not for the cos, but in other instances for substitution. So coming back to our problem, so B is 8, C is 6, and A is 10. So 8 and 6 here. So we're going to get cos A. Now from your calculator, you should be getting, that's going to be a 0. Okay, you shouldn't be surprised if you do get a 0, because if you find cos inverse of 0, that's going to give you 90 degrees. Okay, so the cos of 90 degrees is actually 0. So, okay, I hope you have understood the how to apply the two different formulas, and we'll get some opportunity for you to practice the question in that case on the right hand side. Okay, so you can pause the video again and then practice the questions, and I'll see you on the next slide for the answers. Okay, so here you are for the answers for the cosine rule applications, both formulas, one for the sides and one for the angles. Okay, and lastly, we are looking at concept 4, where we're going to be working out area and exact values. Now, for exact values, I am going to explain a few things here. So what we mean by exact values, this is for special angles. Special angles. Now, in that case, when you have special angles, we're referring to angles like 0 degrees, 30 degrees, 45 degrees, 45 degrees. So we are going to write 45, 60, and 90 degrees. So how does that work? So I'm going to write it here. So 0, 30, 45, 60, and 90. So we got sine of 0, cosine of 0, and tan of the angle rather. So we're looking at the angle. So this is the angle theta, and then we got, okay, 0. So we should be having 0. So I'm just going to modify that, and I'm going to write 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So we start with 0, 1, 2, 3, 4. Okay, and then we divide by 4, all of them, and then you take the square root of all of them. And what you get for this is it's something that you can memorize the steps that I'm going to do, because you actually need to know about this. So 0 over 4 is 0, so square root of 0 gives you 0. Square root of a quarter is going to give you half. Now you cannot get the square root of 2 as an exact value, so you're going to get square root of 2 on top of 2. That's going to give you square root of 3, which is on top of 2. So in fact, you're leaving them in third form. And finally, 4 out of 4 is 1, square root of 1 is 1. So no worry for the second one, because for the cos, you just have to invert the order. It's just going to be the same numbers, but I'm not going to put the square roots this time. I'm going to put 1. This one is going to be root 3 over 2. Then you get root 2 over 2. The next one is half, and the last one is going to be 0. Now, one thing you need to know about for the next one, so tan theta is actually sine theta over cos theta. That's something you need to remember as a formula. So, because that's going to help you in many cases. So what we're going to do is, if you divide sine theta by cos theta, 0 divided by 1 is 0. So half divided by root 3 over 2. So what you do actually is cross out the 2, so you can get 1 over root 3. And you do the same thing across. So, but you're going to get 1 anyway for the next one. And the next one looks like root 3 over 1, which is just root 3. And 1 divided by 0 here is just infinity, right? So remember, the 1 is just such a big number, it's too big, we can't even put it on paper. So it's just infinity. Now, what we're going to do now is, the reason for why we have got this table is because these give us exact values, and it doesn't give you non-terminating decimals if you were to find the actual value from your calculator, but they're not going to give you even the full answer. It's only part of the answer on your calculator. So in that case, we're looking for the area of a triangle. Okay, and so we are having an angle, included angle of 55 degrees, and then we are having sides of 8 centimeters and 11 centimeters. Okay, and you are to find the area of the triangle. So in this example, we are simply applying this formula, which means that area of triangle equals to half A times B sine C. C is the included angle between sides A and B. So that's going to give us half times A, which is, in fact, A is will have to be substituted this time, which is 8, and then you have 11, and then sine of 55 degrees. And that is going to give you, after using your calculator, that's going to give you 36.0 centimeter squared. Now you may be asking, why did we do this then? Because this is going to help us further down for the special angle. Now it says without a calculator, which means you have to use this table. You're going to find the exact value of x if sine x is root 3 over 2. X is obtuse. Okay, so find the value of x. So you are given sine x is equal to root 3 over 2. Now, what does that tell us? So sine x, so if you look at this table, where you get for sine and you get root 3 over 2, which is right here, you're going to get 60 degrees. So sine of an angle gives you root 3 over 2, so that means x is equal to 60 degrees. Now, you might think that this is the answer, but it's only part of the answer because it tells you the angle lies between 0 and 180. So that's where x goes from 0 degrees. You go all the way that way to 180 degrees, and I'm going to draw a dividing line here. That's 90. The reason for that is so I can tell you that this side is going to be acute. If you go anti-clockwise, any angle in between 0 and 90 is acute. Okay, so this is acute angle, and if you go beyond 90 degrees, from 90 to 180, that side is going to be an obtuse angle, so I put B over there. Now, what you need to understand is if you are getting the sine of 60 degrees, so sine of 60 degrees is going to give you root 3 over 2, but that has to be 60 is acute. Now, you will also realize that if you are on that side, which is obtuse, now how do I find that angle? So the idea here is this angle is symmetrical to that angle. So you got 60 on that side, 60 on that side. So we are 60 degrees short of 180. So 60 degrees short of 180 is 180 minus 60. So 180 minus 60, that gives you 120 degrees. So that is actually what the examiner is looking for, because we are looking for an obtuse solution. So x is in fact not 60 degrees, but 180, take away 60, and that gives you 120 degrees. Now there are two things you have learned here is how to use the table right here in order to be able to identify the angle that we just worked out, and you will have to memorize this and therefore identify that angle, but that's not the answer, final answer. You have to use the 60 to find out what the obtuse angle is. So this is a practice that you need to have for your exam. Okay, so we are now going to be looking at some practice questions for you, and so this is going to be on the right hand side for you to practice. Okay, so all the best with this, and we'll compare the answers on the next slide. Okay, you will see that I put that table again for just as a reminder, but the rest should be okay. Okay, finally, we come to the almost the end where we look at what technique we should be using when we have to apply SOHCAHTOA. So that's one of the techniques, applying the formula and combined with the use of the formula triangle, if you like formula triangles. So this SOHCAHTOA is actually meant for finding, is always for right angle triangles. Okay, one side known, one angle known, and one side known. And this is for finding the missing side or angle directly using sine, cos, or tan. The next one, next thing we've learned is about the sine rule, where you are given two angles, and remember this is no longer a right angle triangle, so you need to know two sides, two angles and one side. Okay, and you got the formula for you to work out the missing side. Okay, you can also use that to find the missing angle, just flip it over. We also learn about the cosine rule, where you have two sides and one included angle that is shown. And this is the formula: a squared is equal to b squared plus c squared minus 2bc cos a. Finally, the cosine rule can be rearranged, and I've shown you also how to work out the angle if all the sides are given. So Takeaways from Trigonometry Part 1 Concepts and Skills. SOHCAHTOA only works in right angle triangles. Check for the right angle first. The sine rule needs an angle and its opposite side as a matching pair. The cosine rule handles any triangle when SOHCAHTOA and the sine rule can't be used. We also learn about the area of triangle half AB sine C. It works only when you have two sides and the included angle. Coming up in part 2. So this is all about exam style practice questions, original edXL style questions involving bearings and 3D shapes and angles of elevation and depression and mixed trigonometric methods. I hope you enjoyed this video. Please like, share, subscribe, or comment. Your feedback will help me create more videos like this. So I'll see you on the next video, ladies and gents. So goodbye from now. Until then, it's goodbye. Bye-bye.